Okay, this is 6-54, and it says write the first 5 terms for each of the sequences. And we have a sub n equals 2n minus 5. So we want the first 5 terms. So I guess instead of x and y, I should use n and t of n, because that's kind of the notation that we used for sequences. But just remember, this is kind of just the same thing as x and y. So write the first 5 terms. So the first term would be, that is just when n is 1. So 2 times 1 minus 5. 2 times 1 is 4. Here, let's write it out. Yes. -3. So I'm writing it this way just so I can get my terms, but then when I write my answer, I'm going to write them out horizontally. I'm going to write like -3. Hey, wait, now that we have that, though, now that we have the first term, can't we just go like this? -3. I think it's safe to say that it's adding 2 each time. You want to check it? Maybe we should check it before we make the assumption. Let's try another number. I think there's always a pattern to these. The reason I think it's the arithmetic sequence that adds each time is because if I used x and y, that would be a line. That would be like y equals mx plus b. That's why I know it's adding 2 each time, but we can check. So a of 2 would be 2 times 2 minus 5. And that would be, that's 4 minus 5, that'd be -1. So see right here how it's, it looks like it's adding 2. And if I want to do a of 3, that'd be 2 times 3 minus 5. 6 minus 5 is 1. So do you see how, like, if I show it this way?
So it would be -5, the 0?
Yes, the 0 would. It didn't say to show, it just said to show the first 5 terms, though, so we don't have to do the 0 term. So this is the first term, this is the second term, this is the third term. The fourth term would be, now we can just add 2 each time, can't we? What's 1 plus 2? 3, 4, 5. Those are the first 5 terms. But I like to use a table just because I think we're familiar with tables, and I think it just makes it a little easier to figure it out. And let me check it and make sure it's right, because we're not, let's see, 6-54, because that was letter A. 6-54, A, yes, we're right. So let's do B. So now that we know what we know, it says a of 1 equals 3, a of n plus 1 equals -2 times a of n. Oh boy. So we have a recursive, they call that recursive. Does anybody have any ideas? Oh, we need the first 5 terms, right? So we know the first term is going to be 3, right? Now what?
Isn't that one with the bunch of numbers? Isn't that like the equation for it or something? Like
This
basically, you start at 0, like n plus 1. That would be a 0, wouldn't it?
No, the n plus 1 thing is, do you remember when we learned about recursive equations?
Yes, but all that stuff confusing a lot.
Yeah, it is a little bit confusing. This is saying that if I just want to go from one term to the one right after it, like say I'm on the 3rd term, if I want to go to the 3 plus 1 to the 4th term from the 3rd term, all I'd have to do is multiply it by -2. So what am I talking about? If I have, this is what term, this is the first term, and then we'll have the 2nd term, 3rd, 4th, 5th, right? We're going to put our little answers in here, right? 2nd term, 3rd. If I have the first term, which is a of 1, then if I plug a 1 in there, then I'd have a of 1 plus 1. If I want a of 2, then I'm just going to go -2 times a of 1. What what was a sub 1? 3? And that's going to give me negative 6. So what this thing is saying is that whatever the term is before it, like how do I get to the third term? I have to go the second term times negative 2, because that's what this is telling me. This is saying how you get to the term right after the term you have. Like when you go from this term to this term, don't you have to add 1? N plus 1, and from here to here, isn't that plus 1 and plus 1? So this is n, so if this is n, this is n plus 1. So if I want to go from the first term, which is 3, to the second term, which is, well, I'm not being a good explainer. If I want to go from one term to the next, just by, by ones, then all I have to do right here, it says I'm just multiplying it by negative 2. So basically, this little formula, this recursive formula, is telling me that I just multiply the term before it by negative 2. So that would be negative 6 times negative 2.
Negative 12?
Well, negative 6.
12?
Yeah. That's what a of 3 would be. Would be 12. And then I take that one and multiply it by negative 2. That's kind of what this formula says right here.
Negative 34 and then 48?
So a recursive formula is just a formula that gets you from the term before it. Like it gets you to the next term by using the term before it. So it doesn't, in other words, it doesn't have the 0 term. If I want to make this into a nice explicit equation, all I have to do is find the 0 term. Now we know how to do that, right? We'd have to divide, because if we were multiplying when we went this way, we'd have to divide by negative 2. So this would actually be, I think, right? Because then if I multiplied it by negative 2, it'd give me that. So here's the you don't have to do this. This is not what they're asking. They just want you to give this answer that's in the box. But if you wanted the explicit, you'd go a of n equals negative 2n minus 3 halves. That would be this is the explicit formula, or the explicit equation. That's the recursive equation. Okay, I'm not trying to confuse you. All you really needed to know, or all you really needed to do was just this stuff that's in the box. Just get the 5 terms. I'm going to turn the thing off.